today?
I did try. Yeah, I skimmed it.
Okay, all right. So maybe you need a little more whole milk instead of skim milk. I got you. All right, anything else? Because we will talk about types of error. See what's working today. Oh, hello. That's the first thing we'll talk about. Anything else from homework stuff? Well,
Number 63 on 9.1.
oh. Okay. So can you write the claim?
I don't know what.
So it says here that the most important piece is there good evidence that more than 30% of the teen girls smoke to stay thin?
So to stay fit.
If you don't realize this, don't start smoking, kids. But smoking does keep you thin. The trade-off is you also lose years off your life, but I mean, it's your choice to make. All kinds of drugs will keep you thin. Don't only do certain drugs, okay? So right there, that's all you need to know, to be honest. The rest of it is all a bunch of shit. Is there good evidence that more than 30% of the girls do smoke to stay thin? How do you write that claim in Mathish? Guys, or girls, people. All right. So the claim on that one is, this is 63, right? The claim is P greater than 0.3. Is that going to be the ho or the ha? The ha. And the question is, the alternative hypothesis is, and they give you multiple choice. So there it is. Okay. So write the claim, and then you can figure out which one it is, and the other one is going to be the opposite of that. So if this is P greater than 0.3, what's the hope? Less than or equal to, like.
So would this be fine if I just wrote it like that? Or do I have to expand it?
Oh, so this specific problem we're doing is number 63. 62 is just a bunch of writing in HO and HA just like you did. Yeah.
And then this, I have to explain it or?
No,
will
it
that
just
be-
asked you which one was the
Yeah.
right one. Yeah.
Okay. Homework here?
Sure. Anything else from homework stuff that everybody started last night? That's all I can ask for. Okay, I want to talk about something. We're going to finish out chapter 9, but I want to show you this data. Snow, okay. All right, this is what some people call the blue measles, but this is something I do all the time for myself, but then I like to share it with people. So, for example, real quick, just to let you know, this isn't like a pure number of homeworks done. If you got homework done, I graded it, and it said correct mistakes, you got half credit. So it only counts. So if you did like 6 things and each was half credit, you're actually at 3. Right? You with me? Yes. Okay. So I took everybody. So everybody in here is one of these blue dots. I have condensed you into a blue dot, put you on paper. Well, even without that black line there, you see a trend. It seems that the person that has more homework done somehow has a higher grade. love it. You guys are like, I'm not going to say it. I won't say it, Jeff. Your theories about study and helping. We're going to learn how to calculate this line. What do you think this line is? I think I heard it. I heard it. Average. Okay, beautiful. It's a two-dimensional average. Right? That's why it's not a single number. It's the line that is closest to all the points at the same time. That's what an average really does. It's the number that's closest to all the data points at the same time. What's up? Everybody all right?
We're just guessing which dog we are.
Oh, I see. Sure. You can play that game. Now, to really be honest, I cut out some of the extremes because there are people that haven't turned in any homework, but they're like up here. Yeah, that's you. So that's a special case because I know you are doing work. And this is not perfect, obviously. I haven't looked at a lot of homework yet, and when I do, some of these are going to go this way because some of it's going to need correcting. Some of it might need redoing. You guys kind of follow, but still, this is a decent rough feel, and it's not evidence of shit by itself. This just means there's a correlation. So maybe being a better student makes you do more homework. I don't know. Right, probably not, but you guys semi with me on this? Does this just make sense by itself? We're going to learn how to calculate the line. You see the line of best fit up there, mx plus b? See it up there? Okay. And we're going to learn what the shit this thing is, r. Okay, so that's what we're going to learn from later, after we finish up chapter 9. So we're going to learn how to analyze data and figure out a trend over time. So then you can say, well, what if I did 11 homeworks? What would be my guess for my average would be about just over an 80. That would be the best guess for what your average would be. How do you guys feel about that? Is that all right? A little bit? You don't have to totally understand right now, just get the general idea. Okay. All right. So, I like to show that in general to all my classes, this little thing, because basically it's always this. It's always amazing. Classes, now here, real quick little side note. If I have a class where I let them do online homework, I do the option. Almost always, there's a huge cluster of them here. Who would the people be that are here? What would this person, if there's a person right here, what's that person? Looks like they did a lot of homework, but yeah. So the key word in what I just said is looks like they did a lot of homework. They didn't. So that's why I'm considering just killing online homework entirely. I make it an option because some people do. There are some dots that would be up here that would be online homework because some people do it and it helps them. They do it correctly. Some people not so much. So yeah. Anyway, enough of that. It's just to show you a little analysis I do on the side for all my classes, and that's one of them that I like to show people because this is just a continued attempt to show you what the shit homework is for. Because everybody has a skewed view of what homework is. Okay. All right, so let's finish up chapter 9. We'll start off with this types of error business. So I like to start with a non-mathematical example. Let's do the courtroom thing. I like it. So hypothesis test feels a lot like what a courtroom tries to get at. What is the null hypothesis? This is not going to be mathematical. What's a null hypothesis in any trial that goes before court? What are you assumed until proven what? You're assumed. It is. Now this is I don't mean this to become a sociological class, where we can talk about, supposedly you are assumed innocent until proven guilty. That's why who has the burden of proof? I know this is becoming a AOJ class, but real quick, just to make sure you guys know, who's got the burden of proof, the defense or the prosecutor? Yeah, prosecutor. They're the ones making a claim. This guy killed somebody. Well, prove it. So the defense don't got to say shit if they think the prosecution didn't do a good job. They're like, we're good. They didn't prove shit. We're good. All right. Sorry. So coming back to stats class. So the defendant is innocent. That's the null hypothesis. And the prosecution is trying to show evidence that the defendant is guilty. There will be a verdict, right? There will be something. Let's assume it's not a hung jury or something weird. Let's say there is an outcome. So what's one possible outcome that could come out of this? So again,
Proven innocent.
you never proven innocent.
No, not proven innocent.
I love it. This is a beautiful example about why we say it the way we do. You are never proven innocent, ever.
But you're not guilty.
You're just not found guilty.
Okay.
Yeah, right? You guys with me? You guys understand that? I can't prove somebody's innocent from a sample of information. But from a sample of information, I can show that it looks like they're guilty. That's exactly like any hypothesis test. This one, people can die, go to jail, all kind of shit. So it's a little more high stakes than, smoking, stinking. Okay. So there's what's called a type 1 error that I can make. So type 1 error is rejecting a true null. Oh shit. So reject a true null. So what in this case, now this is, I really want you to understand, whenever I do a hypothesis test, I don't have a frickin' clue what the truth is. You just don't. In this case, the guy killed him, he knows what the truth is, right? Or if he didn't kill him, he knows what the truth is, but he can't let other people in his head, so everybody else has got to go, we're not sure about shit, right? So, but let's just say that somehow we know that the null is true. So in type 1 error, what is the case? What is reality in a type 1 error? What's true? The null. Okay, stay with me. All right, let's take a step back. So in reality, what could be true? The defendant could be innocent. Could truly be innocent, right? You guys with me? That could be true. Or the defendant could be guilty. Are you guys with me? So that could be the reality. We can never prove either one of those things. We can just show evidence for guiltiness or not enough evidence for guiltiness, right? So what if I reject the null when it's really true? In this case, what does that mean? What's true? Let's try this again. Which one is the null hypothesis? This one.
Found guilty but they're innocent.
Beautiful, right? In reality, they are innocent. True null. Don't make too much out of this. Whatever the shit the null is, type 1 error saying it might be true. If it's true and we reject it, isn't that a mistake we made? Beautiful. Does that mean we did our work wrong? No. It's just a possible outcome. There's always a chance we're wrong. Always. How you guys doing? You guys all right? Maybe a little bit? All of this shit is predicated on some level of significance, some plus or minus shit. You with me? Because that's life. That's the within a reasonable doubt. So in this case, they are actually innocent, but we think what?
You're guilty.
Okay, and what do you think a type 2 error would be? It's a type 1
We say
error.
they're innocent. We say they're guilty, but they're actually innocent.
That might not be the best. Yeah, type 2. Just to make it official, this is fail to reject a false null. So those are the two things that could happen, right? We can reject the null, or we can fail to reject the null. So when is it a mistake? I reject a null when it's true. I fail to reject a null when it's false. Those are the types of error. And again, this is a different level of mistake than we're used to. This doesn't mean you did calculations wrong. It's just built in. There's always a chance we're wrong because we don't have all the information. We're working from a sample. I don't know everybody's thoughts at every point surrounding I don't, so I don't have the population of information. So in reality, what's true here? They are, they're not innocent. They're guilty, but we think they are. Now this is a weird question to ask, and this doesn't really come up, but just from your opinion, which one's worse? If we're talking about a murder case. Say again? I like this. This is a neat, we don't have to get too deep into this because it really is sort of a little bit of an opinion. In this case, of course, we're going to kill somebody who didn't do shit. And in this case, we're going to let somebody out in the streets that killed somebody. And maybe they want more of it now. Got a taste for it. Yes?
Because if you have like cancer or something. But if like the likelihood that you have cancer, type 2 would be better, right?
Oh, sure. Okay, so in different situations, one or the other is going to be better or worse. Totally, I love it. So you're talking about like the null is you don't have cancer, and then or actually you assume, anyway, I don't want to get too deep into how medical people look at things, because you try to rule out stuff, right? So you do a test, try to rule something out. I'm assuming this is true, let's do a test to try to show I'm wrong. That's what they do, right? That's what they mean when they say, have you ever heard they're trying to rule something out? So they're trying to show enough evidence that it's not that case. I like it. So medical things might get a little bit wonky with the way they look at it. But you're right. In some situations, type 1 is worse, and in other situations, type 2 is worse. I like it. And in this case, we can't even agree in general. Okay, here the guy might go out and kill more people, but here we're going to kill somebody who didn't do shit. Okay, I like it. I'm not going to try to push any ideology on you. I always try to stay away from that shit, but make up your own mind. So now watch this. All right. Let's try, this is kind of beautiful. If I could just control the probability of which error happens, right? If I could control the probabilities. If this is really bad to happen and that's not so bad, I'd want this probability of making this error to be small. Does that make sense? If this error is like really bad, I want the probability I make this error to be small. What do you think the probability to make this error then would happen? It would become bigger. That makes sense, right? So I do have that ability. Now stay with me. Is everybody cool with this? This is not terribly difficult. It really isn't. If the two things I could say is this guy's wrong or this guy's right, then the two errors I can make are really straightforward. If I think he's wrong but he's really right, that's a mistake. If I think he's right and he's really wrong, that's a mistake. That's why there's two freaking errors. Okay, I love you guys. We can do this. All right, now, I want to connect this with the probabilities. What's the idea of hypothesis test? I know this isn't math. Just go with me, okay? Here's innocent. As a prosecutor, I'm trying to show that there's evidence that they're guilty, right? I don't know if the two-tailed test is good for this visually. Let's say, sure, that's guilty, right? You guys with me? All right, like it's not mathematical, it doesn't really fit, but I don't care. Stay with me. What's the idea? If I find a sample of evidence that puts me here, then that makes it look like the guy's actually guilty. What's the probability that I get evidence that is here when they are really innocent? What's the area of this tail? Who remembers that? Area of the tail. What kind of animal has a tail it uses to go through water?
A shark.
I like it.
A fish.
Fish. So this is alpha. Alpha is the area. Stay with me now. Stay with me. Some of you guys are looking away. But stay with me. Come on. None of this shit changes the work you do. All the little numbers you do. Yay, you get numbers and shit. Yay. But this is the idea. This is why alpha changes. This is cool. I talked about why alpha changed the nuclear plant, get off your ass, all that kind of shit, but this is getting a little more specific. Alpha is the area in that tail. So alpha is the probability I make this kind of error. Alpha is the probability I make this kind of error. I don't know how else to say. So this type of error is bad to make. I'm going to make alpha small. Now, at the same time, the trade-off is it's more likely to make this kind of error, but if that's a much worse error, you guys get a feel for that? It's probabilities. I don't know if I'm actually going to make that error or not, but I want to make the probability I make that error small. You want to increase the probability you get an A on a test. So everything you do should be geared towards making that happen. Will you definitely get an A if you do everything right? No. But you want to increase the probability that you get an A? Yeah. Nothing you do is guaranteed to get you an A. Sorry. Right? Unless you find some corrupt teacher and bribe them. I don't know. I'm not that hard up, so it's not going to happen. Aw, Jeff, why can't your life suck more? All right. I think there was something else I want to say about this and I forgot. That's okay. So alpha is how we're able to control which error is more or less likely. Oh, the nuclear power plant, right? So the nuclear plant would be, on this one, it's all good. So a type 1 error would be what? If that's the null, is all good, what's a type 1 error?
In that situation. Because I think, wouldn't you rather have like a false like alert than like not be aware at all and then?
All right, let's write it down. What's a type 1 error?
So it's
Actually good, but we think it's bad, right? What about a type 2 error?
actually bad, but I think it's good.
Yeah, actually bad, but we think it's good. So do we want, actually bad, like it's gonna blow up, but we are sitting on our ass thinking, we think it's good. We think, okay. All right, now, isn't this worse than this? So you want this probability to be, this probability to make this worse error, you want it to be smaller. So this one you want it to be higher, which would move the tail over, right? So you would get off your ass the minute you get a sample of readings that is there, you're up. Because the probability that type 2 happens is so bad, you want the alpha to be big, which is going to make, like, on the scale, your yellow is going to be, like, huge, and then here's the red. Here's normal, here's yellow. The minute you're approaching that yellow, you're up, right? Okay, maybe. Or, you know, if you've been working for 30 years, like, it does that all the time. Here you go. All right. Yes?
I used to be a resident advisor at.
Oh, I thought you were going to say you used to work at a nuclear power plant.
No.
Resident advisor where?
At CSU Channel Islands.
Okay.
And whenever the fire alarm went off, students would never get up. Like, never get up. Like, we'd literally have to go and bang on their doors. And they're like, no, it's a false alarm. It's
That's funny.
fine. And I'm like,
So again, that would exactly be this.
Days.
All good. So the type 1 error, you want to make that small, so this is, you want to make this big, so this is small. Yeah, so you should be getting up your ass the minute that alarm goes off. It's amazing. Yeah. Well,
Okay.
I was like, I'm tired, man. I'd rather be on fire than move. Okay. You guys okay with that general thing? That's, so you will have to identify types of errors in the homework. And it's just this easy. Whatever the null is, type 1, you say, that is true, and we think it isn't. Right? Whatever the null is. So if the null was P less than or equal to 0.6, P greater than 0.6, right? What would the type 1 error be? We think, yeah, so in reality, P is at most 0.6, right? Because this is rejected true. So here's how I remember it. See how this is a small phrase? Rejected true. That's type 1. Type 2 is fail to reject a false. That's why it's type 2. It's a bigger phrase. That's how I remember it. So type 1, we reject a true null. So in reality, the way you would write in reality, P is at most 60%. But we think it's bigger than 60%. There you go. That's all, right? That's it. So type 1 is the null is true, but we think it ain't. Type 2 is the null is false, but we think it's true. That's it. Because that's the two things that could happen that would be wrong. Okay, maybe, yes.
So a not equal to would be the type 2.
No, it has nothing to do with it. Whatever the null is, the type 1 says if it's true and we don't think it's true, that's a mistake.
Oh,
So if I change it to this, that doesn't really do anything really. In reality, P is equal to 60%, but we think it isn't. That would be a type 1 error. Okay, that's enough of that. It's not a huge idea. It's very direct, to be honest. You guys are getting all tangled with stuff. Just try those out. Okay. So the last thing I got to do in chapter 9 is percentage hypothesis tests, like this one. And the only things that change. Let's do this. I got a little worksheet. Let's do one side together, and the other side you guys will do alone. Alright. Actually, even before I give you this, I want to point this out. What was the confidence interval formula for percentages? I'll get it started. All right, I like it. Plus or minus z times. And then let me put underneath that. Remember, this is the one for means, right? So what is this piece doing? What is that piece in reality? Compare it to. So that is the what for percentages. That's the what. Because what's here? What is this? Standard deviation. So that, and this is in the same place. So this must be the number that represents how spread out. That must be the standard deviation for percentage problems. I'll let you guys stay with me. Come on. Do you guys see that? What in general, what is it? The middle, give or take, z times the spread. The middle, give or take, z times O. That's the frickin' spread. Because that's the idea behind the formula. Whatever number's there must represent the spread. I like it, maybe. So, for means, step number 4 looks like this, right? Right? It does, so yes. I just want you to look at that and say, that looks familiar. Of course, this is the part we would do on the side, right? So for percentages, if I'm doing a hypothesis test about percentages, step 4 is going to involve a z-score formula that looks like this. My data minus the accepted middle divided by the standard deviation for this situation. The difference between, when I'm making a confidence interval, do I know the actual value of P? No, that's the whole purpose of the confidence interval, is to give some estimate for what P might be, or give a rough idea. In a hypothesis test, I'm assuming I know the population information. So when I do this, I'm not going to use the hatted ones, which I think is a great band name. But I'm not going to use the hatted dudes because in a hypothesis test, I assume I know the real story. That's the one little difference. Here I don't know, so I use the hatted ones to be estimates. Here I do know. I'm not going to use hats on them. The main thing I want you to realize is I can't use the same stupid z-score formula because with percentages I don't know all this shit. So I need the one that works for a percentage situation. And in fact, we created this from the same place this came from, but we just put information about what's true for percentages. So it makes sense to go and say, we already did a bunch of work here. Let's just steal this. Okay, I like it. So what does that mean? It just means on step 4, when I go to calculate z star, I'm using that stupid formula instead of that one. So which one do I use when? Well, if you got a percentage problem, you probably should not use the one that's got no percentages in it. Don't try to force it into this. Or put a little note, you didn't give me sigma, so I can't do anything. It's percentages. So don't use that formula. Okay, so here we go. We're gonna do this first side together. First side's about police in Chicago. Based on a Gallup poll. Let's do this one together, and then I'll make you do the back on your phone. Bless you. Oh, if you need to borrow calculators, do that real quick. Doing that on that chocolate. Breakfast of sham.
Balance.
That's breakfast dessert. What are you guys talking about? Okay, so hopefully everyone's read through that statement. One about Chicago policemen, not the one about, what was this one about? Oh yeah, passing this class, okay. So what is the claim?